This is 6.3, Exponential Functions, Part 1. An exponential function is a nonlinear function of the form y equals a times b to the x power, where a is not 0. If a were 0, this whole thing would be 0. So this is different because it's nonlinear, and the x is in the exponent position. We know it is an exponential function if consecutive y values form a constant ratio. So instead of a constant rate, it forms a ratio. So if I look at this set of values, to get from 3 to 6, 6 to 12, and 12 to 24, multiply by 2 each time. If I take 24 divided by 12, consecutive y values right next to each other, divide, I get 2. If I do 6 divided by 12, that's 2. So I know that they're the same. It is constant. It is a ratio because I am multiplying or dividing. So we're going to determine whether the function is linear or nonlinear. Here's hints for which is which. So here, to go from 4 to 8, 8 to 12, 12 to 16, those would be adding 4 each time. So we say this one is linear because the y values increase at a constant rate. It has a constant slope. Now for these two, or these ones, to get to each next y value, I look and see that I will have to multiply by 3 each time. So this one, if I could test it, and this one would be nonlinear. It's actually exponential because the y values increase at a constant ratio. And here's one more. To get to each number, they're not increasing, so I'm going to have to somehow get the numbers smaller. And I would divide by 5 each time. If I test it, I would get my answer as 1/5. Multiplying by 1/5 is the same as dividing by 5. So this one's exponential. The y values change. They actually decrease at a constant ratio. Now we are going to evaluate each function for the given value of x. So I have y equals 3 times 2 to the x power, and x equals 4. I'm going to take this 4 and plug it in to my function and calculate what number that is. So when I do that, I get 2 to the 4th, which is 16. 3 times 16 is 48. Now for this function, I'm going to plug in -2. That gives me an exponent with a negative number, so that means it moves to the denominator here, and then I simplify and reduce that. And I get -4/9. Now when we graph exponential functions, there's a couple ways that they could be. If we have b is larger than 1, so the number that is being raised to an exponent is bigger than 1, it will look like a j, this orange one, or an upside down j. It depends if a is positive or a is negative. Now if b is between 0 and 1, then it will look like an L or an R. L-shaped if A is positive, R-shaped if A is negative. If you have to graph these, the easiest way to do that is to make a table of values, then graph the points. So this would be where you make your table. Pick x's like these ones. Don't choose too big of x's because it's either going to grow really big in one way. So keep it kind of small, figure it out. Then you're going to take your x's, plug it into the function that you are given, and then you can graph those points.